Hey everyone, welcome to my very first video on this channel. My name is Soroush and I'm the founder of Math Ideas. First off, what exactly are we here to do? Our first project is all about Math Olympiads. We've noticed that many resources and Olympiad classes tend to follow a confusing process, discussing problems with different ideas in no clear order, and often explaining solution in a way that leaves us wondering about the main idea behind them or the philosophy and the motivation behind them. We're here to change that. We're building a collection of ideas and problem-solving strategies that will bring us a new, fresh way to learn mathematics. This week, we kicked off something truly exciting on AOPS, the Soroush Weekly Geometry Challenge. And yes, I named the challenge after myself. Every Sunday, I invite students to share their toughest or most interesting geometry problems. Then on Thursday, I choose one problem to feature in a video. Today, I'm excited to share our very first chosen problem and walk you through its complete solution in the Math Ideas style. So let's dive in and see what this week's problem is.
Math Ideas. A deep insight into mathematics.
Let O be the circumcenter of triangle ABC. Line CO intersects the altitude from A at point K. Let P and M be the midpoints of AK and AC respectively. If PO intersects BC at Y and the circumcircle of triangle BCM meets AB at X, prove that BXOY is cyclic. I suggest you to pause the video for a few minutes to really think about the problem, then come back and watch the rest of the video. What do you think is the best way to start solving a problem? Take a moment and think about it. The first step is to analyze and review the hypotheses and the conclusion of the problem. It might sound simple, but if you really master this step, you'll be able to tackle a large portion of Math Olympiad problems. There is a lot to discuss on this topic, and I might even create a separate video on it later. But for now, I just want to emphasize that without doing this analysis, you won't truly understand the problem and its challenges. So if you jump into brainstorming ideas before analyzing and identifying the challenges, chances are your idea won't work. This is the common mistake many beginners make. Okay, let's start working on the problem. As I said, the first step to work on a math problem is to analyze the hypotheses. So for example, we can start from point O. O is the circumcenter of triangle ABC. And if we draw the lines OA and OB, we will have OA equals OB equals OC. And if I call angle OCA as alpha, we will have OCA equals OAC equals OAB. In fact, all of them are equal to 90 minus B. We will also have angles OBC and OCB. They are equal to each other and they are both equal to 90 minus A. Okay, now let's analyze the fact that P is the midpoint of AK and M is the midpoint of AC. Using these two facts, we can conclude that PM is parallel to KC. So we have PMA equals KCA. So PMA is also equal to alpha. Now let's analyze the fact that BXMC is cyclic. One way to analyze that is that angle B equals AMX, and also angle C equals AXM. If you look precisely to the problem, you can see that angle AMX plus XMO equals 90 degrees, because M is the midpoint of AC and O is the circumcircle of triangle ABC. So OM is perpendicular to AC. And since alpha is 90 minus B, we can conclude that XMO is also equal to alpha. Also, we have MX is perpendicular to AO, because AMX plus OAM is B plus alpha, which is 90 degrees. Now if you check, you can see we have analyzed all assumptions in this figure. So let's go to the next step. The second step is to analyze the conclusion. So the conclusion is to prove BXOY is cyclic. How can we prove that this quadrilateral is cyclic? We have two ideas to work on this quadrilateral. The first one is to prove that angle XBY equals POX, or in other words, POX equals B. And the second approach that we can have is to work on angle OBY and angle OXY. We need to prove that they are equal to each other. So based on the approach that we choose, we can have two different solutions. Let's work on the approach to prove POX equals B first. If we want to prove the equality of these two angles, we don't need point Y anymore, because the definition of angle POX and angle B are completely independent from point Y. So I can erase point Y, segment OY, segment XY, and this circle. I don't even need to prove that BXOY is cyclic anymore. Okay? And I can also erase line BO because I don't need it anymore. Okay, so this will make our figure a bit cleaner. Now we've finished the first two steps. But if you think about it a little, you'll notice that it's still not clear how to complete the proof. Unlike many problems that can be easily solved after analyzing the assumptions and the conclusion, more challenging problems still require some extra work. This is where brainstorming and ideas come in. Our teaching style is all about that, sharing those breakthrough ideas. Alright, now take a moment to think more about the problem and try to come up with the idea that will lead to its solution. You can pause the video again. Okay, let's continue. You've probably guessed that the similarity of triangles AMX and POX will finish the problem. To prove their similarity, we need to show that angles AXM and PXO are equal. Or in other words, AXP equals AXO. But let's take a closer look. Doesn't this structure look familiar? Would you agree that it's very similar to the one we see with isogonal conjugates? The isogonal conjugates theorem says that if three Sevian lines meet at one point, say x, then their reflections with respect to the angle bisectors will meet at one point, say y. And y is being called the isogonal conjugate of x. But for isogonal conjugates, either both lie inside the triangle or both lie outside it. So let's think a bit further. Hold on. We know that these two lines are perpendicular to each other. So what if we reflect O across this line? Let O prime be the reflection of O with respect to line MX. We can easily say that O prime is the isogonal conjugate of point P. Since these two angles are equal to each other and these two angles are equal to each other. And then we can conclude that these two angles are equal to each other, and since O prime xm equals OXM, we can conclude that OXM equals AXP. And this will finish the problem. That's it for the first solution. Now let's move on to the second solution. That is the second method in which we analyze the conclusion. In this approach, we needed to prove that OBY equals OXY. However, a clear relationship between x and y and their corresponding angles does not emerge. In cases like this, when we want to prove that a quadrilateral is cyclic, but two of its vertices seem unrelated, what idea can we use? Think about it. The idea is to add an auxiliary point that lies on the circle passing through these 4 points and establishes a good connection with x and y. This auxiliary point essentially acts as an intermediary that links x and y. But how do we find a good auxiliary point? Let's focus on this part of the problem a bit more. Doesn't it seem familiar? How do we find the suitable point on this circle? If we extend AO until it cuts the circle at Z, then by writing the power of point A with respect to the two circles, we observe that quadrilateral ZOMC is cyclic. Thus, Z turns out to be an appropriate point. Returning to the problem, if we extend AO so that it meets the circle passing through X, O, and B at point Z, we know that Z lies on the circle through M, O, and C. The midpoint of BC, which we call N, also lies on that circle. Therefore, angles CNO and AZC are 90 degrees. Now, we need to prove that Y lies on the circle passing through B, X, O, and Z. For that, it's enough to show that angle OBY equals angle OZY. But since angle OBY equals angle OCY equals angle OZY, we need to demonstrate that ZO is the bisector of angle NZY. To
To prove this, we can either use the basic methods by setting up some ratios, or employ the method of harmonic rays. I will use the second approach and leave the first one for you to explore. From point Z's perspective, it's sufficient to show that the rays Zn, Zo, Zy, and Zc are harmonic. Note that angle OZC is 90 degrees. Now, looking from point O, we need to prove that the rays ON, OA, OY, and OK are harmonic. Since OP is the median of AK and ON is parallel to AK, since both are perpendicular to BC, these four rays are indeed harmonic, and the problem is beautifully solved. Alright, this completes the solution for this problem. And finally, here are some nice exercises for you. You can work on these problems to practice the ideas we covered today. Feel free to email us your solutions for review. Also, check out the next week's challenge on the latest post of our AOPS account. I've included a link in the caption. Okay, I hope you enjoyed this lesson. Goodbye.
Math Ideas, a deep insight into mathematics.